Okay, this is Unit 2. We were looking at Example 3. This one is a little bit different because we have an initial upward velocity. A ball is thrown vertically upward with an initial velocity of 50 meters per second. And in general, with free fall type problems, up is positive, down is negative. Your initial velocity is positive 50 meters per second. Find the ball's velocity after 2 seconds. So we want to know velocity. There's VF. After 2 seconds, there's T. The formula that relates velocity and time. Initial velocity plus the acceleration times the time. Final velocity equals positive 50 meters per second plus the acceleration of gravity is down, negative 10 meters per second squared. And what's the velocity after 2 seconds? Final velocity equals 50 minus 20. I'll write that in. 50 meters per second minus 20 meters per second. Final velocity equals 30 meters per second. And at this point in time, it is traveling up at 30 meters per second. So, let's see if I can get this work. Nope. So here's what we're looking at. Really, so here's the ground. And we have a ball being thrown with an initial velocity. Here it is after 1 second. Here it is after 2 seconds. Here it is after 3 seconds. How high is this thing going to go? Well, remember, if this is 50, 1 second later it's moving 40, 30, 20, 10, and the max height would be 0 meters per second. This is where our velocity equals 0. And then so 1 second later, here, another second, and another, and another. So it is being accelerated downward at 10 meters per second squared every second. So it's slowing down on its way up, velocity is 0, and then it's being pulled back down at the same rate. Find the velocity after 4 seconds and then after 6 seconds. So we are looking for VF and 2 different times. One formula that relates velocity and time. So final velocity. Initial velocity is 50 meters per second. Acceleration is negative 10 meters per second squared. And in the first example, the time is 4 seconds. So what we have is 50 minus 40, and that is, 10 meters per second. And this agrees with what we were looking at here. After 4 seconds, so 50, 40, 30, 20, 10. And here's the numbers backing it up. After 6 seconds, so we're going to use the same formula. Initial velocity is 50 meters per second. Acceleration is still -10. It's gravity. The only thing that changes here for our given numbers is the time. And for this one, we have 50 minus 60. Final velocity is -10 meters per second. And this makes sense too. Again, 50, 40, 30, 20, 10, 0, -10. Now it's falling. Part C says, how long will it travel upward? Well, we've been talking about it on the sketch. Now we can back it up with the formula and the numbers. Final velocity equals initial velocity plus the acceleration times the time. So how long, we're talking about time, how long will it travel upward? We want to know t, and so we know initial velocity, it's 50. We know acceleration is -10. Final velocity. So here's what happens. It's being thrown up, it's slowing down, slowing down, slowing down. At the very top, its velocity is 0. So for an instant in time, final velocity is 0. And that's how we can do this problem. So we're going to have to subtract 50 meters per second over divide both sides by -10 meters per second squared. So we have time of -50 divided by -10. It travels upward for a total of 5 seconds, just like in our diagram. Find its maximum height. There are several different ways that we can do this question. Find its maximum height. So one way we can do this is distance equals initial velocity times the time plus 1/2 acceleration times the square of the time. We're looking for d, distance. We know the initial velocity, we know the time because we figured out in this question C, and we also were able to figure it out just by making our sketch. And the acceleration is always going to be -10 unless there's a special circumstance, and this is not. Distance equals, so our initial velocity is 50, time is 5 seconds. Times 5 seconds, and that quantity is squared. So distance here, we have 250 meters plus -125 meters, and that gives us a distance of 125 meters. This is the height that it traveled into the air. Some other possibilities, you could use the formula, let's see, draw a line here. Second formula, final velocity squared equals initial velocity squared plus twice the acceleration times the distance. This one works because it includes distance in the formula. We know acceleration of gravity, we know the initial velocity, and we know the final velocity. The velocity at the peak is 0. So what we can do is say 0 equals, and we have, let's see, 50 meters per second, quantity squared, plus twice the acceleration, which is -10, and there's b. And so what we have is, this is going to be negative. I'm going to go ahead and add it to both sides. So we have 20 meters per second squared times d equals, and 50 quantity squared is 2,500 meters squared per second squared. Dividing the whole thing by 20 meters per second squared gives us distance equals 125 meters. So you get the same answer using both methods. Personally, I think the distance formula was easier in this one, but that is another possibility. Third possibility, like we've been doing, this would be like method 2 for the other ones. Distance equals average rate times time. Distance equals, and our average rate, so we're talking about maximum height, it's initial velocity plus final velocity divided in half. So our initial velocity is 50 meters per second, plus our final velocity at its max height is 0. We're going to divide that by 2, and the time here is 5 seconds. And so we have distance equals 25 meters per second times 5 seconds. And again, we get 125 meters. So 3 methods here, we could all find the same thing. How high will it be off the ground after 8 seconds? So we are relating distance and time. Formula that relates distance and time, this one. So let's start plugging in our numbers. The initial velocity is 50 meters per second. Time, 8 seconds, plus 1/2. Acceleration is -10. And the time is 8 seconds. And we need to remember to square that quantity. So 50 times 8, 400 meters, seconds canceled, plus, let's see, we've got 8, 16 by 8. 64 times 10 divided by 2, 320 meters, and the distance is 80 meters. At what time will it be 90 meters above the ground? So we are relating distance and time again. Here's the formula that relates distance and time. We want to know when it's going to be 90 meters above the ground. Above the ground tells us positive. It is up 90 meters. Initial velocity is 50 meters per second. We're looking for time. 1/2 gravity is negative 10 meters per second squared. And there's t squared. So let's simplify it and drop the units for a little bit. 90 equals 50 times t minus 5t squared. And so let's add these two, or add this one to the other side, subtract this one. So positive 5t squared minus 50t plus 90 equals 0. Again, looking at this, I see that all of these are divisible by 5. So we have t squared minus minus 10t plus 18 equals 0. This one you are best off using the quadratic formula, in case you have forgot it. Here's your quadratic. Using the quadratic formula, we will find that time equals 2.35 seconds and time equals 7.65 seconds. So what this is telling us is that it's traveling upward. After 2.35 seconds, it has hit that 90 meter mark, and it's continuing to go up for a few more seconds, and then it starts to fall, and at the 7.65 second mark, it has reached 90 meters again and continues to fall. Some rules for up and down motion. I've described some of these throughout these last few videos. Here we're going to put them all in one list. Rule number 1, up is positive. Down is negative. Rule number 2, at the peak, velocity equals 0. For a brief instant in time, but for some point, velocity is 0. Another rule for up and down motion. Time up equals time down. Another rule that we haven't really addressed much yet is that catching speed, or you could say the speed that it hits the ground, equals throwing speed. This is where you have one like on the drawing that you have on the previous page, I guess this page, where We threw it up and it went up for 5 seconds and then hit the peak and then it came down for 5 seconds. Its speed at 0 up was 50. And if we calculated its speed as it hit the ground, it would have been negative 50. So catching speed equals throwing speed. Rule number 5 is especially important because it gives us some specific ways to deal with problems. Once it reaches the peak, it acts just like a dropped object.